Hi everyone! Today we're going to study integration by parts. Let us derive the formula. Let u and v be functions of x. The product rule of derivative for uv is derivative of uv equals u dv plus v du. Now we will do the reverse. We will take the integral of this equation. So we will have the integral of duv is equal to the integral of u dv plus the integral of v du. The left side here can be simplified into uv equals the same right-hand values. Now, this integral of v du we're going to transpose on the left side. This plus sign becomes minus. So we have now uv minus the integral of v du equals integral of u dv. Let us interchange the position of the left side and the right side members respectively. So we have now the integral of u dv equals uv minus the integral of v du. This formula now is what we call integration by parts formula. Next, we will study how to use the formula. Given an integral of the form, the integral of product of two functions f of x times g of x dx. Step 1 is we will choose one of the functions as variable u and then the other function with the dx as dv. Thus translating the integral into the form integral of u dv. The next question is how to choose the function u among the two functions here. This acronym will help us in choosing u. I-late. The letter I stands for inverse functions. Examples are sine inverse x, cosine inverse x, and tangent inverse x. The letter L stands for logarithmic functions. Examples are log x and natural log of x. The letter A stands for algebraic functions. Examples are x raised to 5, 4x, and any non-zero constant. The letter T here stands for trigonometric functions. We have the sine x, secant x, and cotangent x as examples. The letter E here stands for exponential functions. Examples are e raised to x, 7 raised to x. We're going to take the variable u based on this priority order lists. Let's go now to step 2. After choosing the function u and the dv, we will now do this. For the function u, we will take the derivative, and that will be the du. For the function dv, we will take the integral, and eventually we will get the function v. Step 3. Substitute the values into the integration by parts formula. That is the integral of u dv equals uv minus the integral of v du. Then step 4. Evaluate the integral. Let us see this example. Use integration by parts to evaluate the integral of x sine x dx. Step 1 is we are going to choose which function to be the u. We have two functions here, the x and sine x. The first function x is algebraic, while the second function sine x is trigonometric. With respect to our acronym ILATE, the letter A that stands for algebraic comes first, then the T that stands for trigonometric. So we will take the u to be that algebraic, which is x. So we write here the u equals that function x. Eventually, the dv is equal to that sine x along with the dx. We will take derivative of u and we will take the integral of dv. So we have now derivative of u to be du is equal to derivative of x is dx. While here we will show that the integral of dv is equal to the integral of sine x dx. The integral of dv is simply v, and this is now equal to the integral of sine x dx is negative cosine x. In here, we will no longer write the plus c. Then step 3, we're going to substitute the values into the integration by parts formula. So this integral of x sine x dx is now equal to the integral of the x is the u, so we write here, and the sine x dx is the dv. And this is equal to the uv minus the integral of v du. Let us now substitute the uv. We have now the x for the u and negative cosine x for the v. Then minus the integral of v. Now this is negative cosine x and the value of du is dx. So we copy it here. Step 4, let us evaluate the integral. This x times negative cosine x, we're going to simplify as negative x cosine x. And then this negative of cosine x here, we will pull out of the integral sign, but because of this negative sign, it will be positive here. So we will evaluate the integral of cosine x dx. And this is now equal to sine x plus c. This is the final answer. I hope you learned something from this video. See you again next time.